Okay, today we're looking at patterns and graphs and how they go together. So let's read the first problem. Mina uses green and red ribbons for her design. The length of the green ribbon's G is always twice the length of the red ribbon's R. Write a rule to describe Mina's design and plot 4 points on the graph to show the pattern. So let's go back and look at the words inside the problem that help us outline an expression or an equation. So I see the length of green ribbons G, and then I see this word is. The word is always denotes an equals sign. So I can go ahead and start down here that G equals, because the length of the green ribbon's G is. That's G equals. And it says that it's always twice the length of the red ribbons R. So if I want twice the length of the red ribbons, that means I'm going to multiply the red ribbons times 2. So my equation for the rule is G equals 2R. And then I can go ahead and create a small input-output table. And I need to decide before I go any further which of these G or R, green or red, which one is my input and which one is my output. That will also help me label my graph. So the input is the one that is being crunched. The output is going to be the answer. So that means that G will be my output. I'm going to put it over here on the y-axis because the output is always on the y-axis. And the input is always graphed on the x-axis. So I'm going to graph red down here on the x-axis and call it R for red. Then I'm going to go over here to my input-output table. And since red is the input, it's my x value, it needs to go on the left. So I'm going to put R on the left. And you can go ahead and put x and y there too to help you remember that that correlates with your graph. The y values are G for green. Those are the outputs. So now I'm going to choose some simple numbers to put on my graph. So I'm going to start with 1, 2, 3, and 4. Anytime we get an opportunity to work with simple numbers, we do. So if red is 1 and green is twice red, that means if red is 1, green is 2. And I can graph point 1, 2 over 1 from the origin up 2 on my graph. If red is 2, green is 4. Over 2, up 4. If red is 3, green is 6. Over 3, up 6. If red is 4, then green is 8. Over 4, up 8. And then I can see that this is a constant pattern of multiplying 2 times R to equal G, and it forms a line. Let's look at the next one together. We're going to do the same thing this time. Rita uses red and blue ribbons in a design. The length of the blue ribbon B is always 3 inches greater than the length of the red ribbons R. Write a rule and plot 4 points on the graph to show the pattern. So we're going to do the same thing. We need to decide which one's the input, which one's the output, form a t-chart, and graph 4 of those points. So let's go back like we did up here and look at the wording in the problem. So the length of the blue ribbon, we're going to call that B, and there's that word is again. And is always shows us that that's going to be our equal sign. So far I have B is. B equals 3 inches greater than the length of the red ribbon R. 3 inches greater is the same thing as adding 3 to a value. So I'm going to start with B equals R, and if I add 3 to that, that's going to equal the value of B. So here I have a multiplicative pattern, and now I have an additive pattern. So I'm going to draw a t-chart again. This one's going to be pretty skinny. And I need to decide what's my input and what's my output. R is the number that's being crunched. So we're adding 3 to R. So that will be my input. So red goes down here on the x-axis because the input value always goes on the x-axis. And then blue is going to be my y value because it's the output, and the output always goes on the y-axis. So I'm going to put red here and blue here. And we need to again find 4 points to graph. So we're going to start with 1, 2, 3, and 4 for R. So if R is 1 and I add 3 to make B, that means B would be 4. And I can graph from the origin over 1 up 4. If R is 2 and I add 3, that means B would be 5. So I can graph this point over 2 and up 5. If R is 3, I graph over 3 and up 6 because I'm adding 3 to R. And again, add 3 to 4, that makes 7, and that point would be at 4, 7. And if you notice, this line is much steeper than this line because this is a multiplicative pattern. It grows faster. My outputs are going to grow at a faster rate than here where I have an additive pattern and my outputs are going to grow at a slower rate. And that's putting together patterns with graphing.